So in lesson 3.2.1, we're continuing our delve into similar shapes. And in this, we started the lesson off by measuring a whole bunch of stuff from two similar triangles. And I just rewrote kind of what we figured out. So again, after measuring, we figured out that similar shapes will have proportional sides. And all that means is that the sides grow the same. So all three sides on a triangle will have the same zoom factor or ratio or scale factor, whatever you want to call it. That's a dilation for you. All the sides grow the same or shrink the same. It depends on what the scale factor is. And then similar shapes we just measured will have congruent angles. So similar triangles will have all three angles the same. In the big guy and the small guy, they will have all the angles that are the same. So the next part is every time I give you two pictures of a triangle and say, are they similar? You are not going to pull out your ruler and your protractor like I have right here and say, ooh, well, let me measure everything and make sure all my angles are the same and all my sides are proportional. You're not going to do that. So we are going to look for shortcuts. So our similar shapes, there are shortcuts in order to figure it out with triangles. So the first shortcut that we're going to talk about, I normally have you all take out a piece of paper and I say, okay, everybody, make any triangle you want that has an 80-degree angle and a 45-degree angle. And you take your little protractor and you draw a shape, a triangle on your paper that has an 80 and a 45, and then I have you cut it out. I have everyone in the class do that. So I did it 4 times because I was trying to imitate my class. And then I walk around and say, okay, let's see how yours compares to mine. So let's say mine is the green, and let's say one of you turned me the red one. And I place them like that. Can you see that the red one is a dilation of the green? Or vice versa. The green one is a dilation of the red. So we still have this side right here is parallel to that side. That's true in a dilation. And then our angles are the same, which means we have equal angles. So the shapes are similar. Let's try another one. Here comes another one of an 80 that has an 80 and a 45. So I place it on top of my green one, and voila, the yellow guy is similar to the green guy. It's just a dilation that was made. And then I did another one, the blue, same. I took, and you can do this at home, any 80-degree angle and 45-degree angle in a triangle will be similar to the other 80 and 45-degree angles in triangles. There is no way to make a triangle with an 80 and a 45-degree angle in it so that it wouldn't be similar to all of these. Okay. Which means, what was the smallest information that I provided you and we came out with all these similar triangles? I gave you 2 equal angles. I gave you 2 angles that had to be equal. So shortcut, similar, triangle, shortcut. Number 1 is angle, angle, similarity. So A stands for angle, A stands for angle, and the similar sign. Because what I said was, I would have told the whole class, make any triangle you want that has an 80-degree and a 45-degree angle in it. Every single one of yours would have been similar to mine. So this just means, and I'm going to define it for you, if 2 corresponding angles in triangles are congruent, then the triangles are similar. That's what it means. So this is the shortcut number 1, angle, angle. So anytime you have 2 equal angles in a set of triangles, so for instance, let's say I gave you these 2 triangles and I said, are they similar? Instead of measuring everything, you can say, ooh, there's an 80, there's an 80, that's 1 equal angle. Here's a 45, there's a 45, there's 2. Instantly you know they're similar. You got it, done. So all you need to know for the shortest shortcut is angle, angle, 2 equal angles. All right, then the next one I would have had you do in class is I would have said, all right, everyone, here is my triangle that I have. It has a side 1 inch, 120-degree angle, and then a side 2 inch. And this is accurate. I drew it to scale. So this is what I would have put on the board. And I just said, all right, you pick a zoom factor. I don't care, pick whatever zoom factor you want. And you have to use that zoom factor on the two sides. And you have to keep the 120. So yours is going to have a zoom factor for the two sides, but the angle in the middle has to stay 120. And here we go. Here is someone in the class. This is what theirs looks like. So they did a zoom factor of 2. They doubled this side and they doubled that side. And they did the 120 in the middle. And if you look, lo and behold, they're similar. This is a dilation. The blue is a dilation of green. Green is a dilation of blue, however you want to view it. Here's another one. So this is a zoom factor of 3 from my original green one. So they tripled both of the sides and kept a 120 in the middle. Ta-da! We got a zoom factor of 3 and now it's similar. Done instantly. So again, I don't have any measurement on this last side, but I still am saying I have a dilation. You can tell we have a dilation. So even though we don't have measurements on the third side of the triangle, it still is a dilation, which means it's going to hold the same zoom factor as the other set. So my yellow one is a zoom factor of 4, and you can see that all of these colored triangles are similar. They're just dilations of my green. So they just continue to grow bigger and bigger. Okay. So the question is, what's the shortcut? So let's go back to the beginning too. Information I gave you was a side, an angle, and a side. And you doubled the sides and you kept the angle the same. So this is called shortcut number 2, and it's called side, angle, side similarity. And what it means is if two corresponding sides of triangles are proportional, that just means they have the same zoom factor. If two corresponding sides of triangles are proportional and the angle in between them is congruent, then the triangles are similar. Okay. And so that just means that two sides on my triangles, two sides, are proportional. This doubled and the other side doubled, so they're proportional. They have the same zoom factor. The angle in between those two sides is both 120. Instantly similar shapes. So even though we didn't have any information about that third side, we now know that it's going to double. So this green side to the blue side is going to be a double to get there. Okay. All right, so this is a shortcut. And then the third shortcut, I'm not going to show you because it's the definition of dilation. Side, side, side similarity. That just means if all three sides on triangles, all three, I should say corresponding, all three corresponding, caret down, corresponding sides on triangles are proportional, then the triangles are similar. And that is the bare definition of dilation. So when we dilate something with a zoom factor of 3, we triple all the side lengths. So that makes similar shapes, and that's what our definition is for side, side, side. So at side, side, side is just dilation, and all dilations are similar. So those are our 3 shortcuts for similar.